Hey physics friends, welcome to 5.3 homework problem solution set. I'm going to be taking you through these 6 questions that I gave you guys to work on, just so you can see maybe if you went wrong someplace or what techniques that I use when I'm solving a problem like this. Let's get started. Number 1 says the box below is initially at rest on a frictionless incline. So that's first of all, that's really important that it's frictionless. And that means that there is no friction. So pretty self-explanatory. How much time does it take to slide 10 meters down the hill? So we're looking for how much time. So time equals question mark. We know that the displacement that it's going to occur is 10 meters. We know that it's initially at rest. That's big. Its initial velocity is equal to 0. What I'm going to do, I think where I'm going to go, I'm going to look for the acceleration, and if I can then find the acceleration, I'm going to plug it into this equation, d equals vit plus 1/2 at squared. So that's where I'm aiming. I'm aiming to find the acceleration, and once I find that, this problem is licked. Let's get started. Draw a picture, label your forces. There's a force of gravity pulling straight down on this box. So if you take 10 and you multiply by 9.8, you get 98.0 as the force of gravity. Newtons. There's a normal force acting on this box. Now, normally there would be friction, and it depends on which direction this thing is moving. If it's moving up the hill, friction opposes your motion. If you're moving down the hill, friction opposes your motion. So friction is one of those forces that kind of goes on either side, but because this is frictionless, we don't have to worry about friction right now. All I'm going to do is I'm going to find the normal force, and let's do that by breaking this gravity into the y component, which we call the force perpendicular, and the x component, which we call the force parallel. We know that this angle right here is also 30 degrees. So the force parallel is going to be 98 times the sine of 30. And if you take 98 times the sine of 30, I know because it's a 30, 60, 90 triangle, that's going to be half. So that's going to be 49 newtons. And then the force perpendicular, it's 98 times the cosine, which is going to be equal to 84.9 newtons. So now I know this thing is being pulled down the hill at 49. I can get rid of gravity because I've replaced it with its x and y components. So the normal force is equal to 84.9. So here you've got a box that's being pulled into the incline at 84.9, and the incline is providing some equal and opposite reaction force, 84.9, and it's being pulled down the hill at 49. Now I can find my acceleration. If you remember back to the previous unit, when we would do 2 units ago, well, no, it was the last unit, F equals ma, and we put the net force in here, these two forces are canceling each other out, so this is 49.0, and my mass is 10, so now I can find my acceleration. Now I take that acceleration, plug it in over here. I got the problem licked. So I want to know the displacement. My initial velocity is 0, so it's 1/2 times the acceleration, 4.9 times my, I know the distance, 10, and I'm looking for the time squared. So you take 10 times 2, which is 20. 20 divided by 4.9 is probably like 5, and then the square root of 5 is probably something around 2.5 or something like that. So 2.02. when you end up solving this. Seconds. There's your first one. And in general, it kind of goes along with the process that we've been working on so far. Step 1, look for diagonal vectors. And in an inclined plane, the diagonal vector is gravity because we've tilted our x and y. Step 2, replace, step 1 is look for it and then replace it. And now we're summing up forces. So we're kind of deviating from the whole steps, and we used to do the Pythagorean theorem and inverse sine and cosine, but now we're looking for, there's excess force here. Let's go to number 2. Same box. It's initially moving up the frictionless incline. So this thing is traveling this way. So its velocity is in this direction with a speed of 10.0 meters per second. How far does it slide up the ramp before it starts sliding back down? So I'm going to take some of the same numbers that I had from last. I knew that the force of gravity was 98, right? And then I knew that my force perpendicular was 84.9. And I knew that my force parallel was 49. And I knew that my normal force was 84.9. So I'm pulling these numbers from the last problem to just get a sense of, and because I have a smartboard, I can kind of do this stuff. And then also, my acceleration is still the same. Like when these are my forces here, because it's still frictionless. When I do that whole net force, my net force is still 49. My mass is still 10. So my acceleration is still 4.9. Now, but here's where it's kind of tricky. And I kind of skipped a little bit of steps last. One of the first things I should do is denote which direction do I want to be positive. Do I want up the hill to be positive, or do I want down the hill to be positive? And you know what? I'm going to make down the hill the positive direction, just because that makes this a positive 49. So my acceleration is still positive 4.9. So in this problem, everything is kind of the same except for the initial velocity. Remember how in the last problem we were looking for all these parts right here? My initial velocity in this case is going to be negative 10. Because I'm going up the hill, and up the hill is going to be negative. So my acceleration is still positive. It's going down the hill at 4.9. My how far? So I'm looking for the displacement before it starts sliding back down. When it starts sliding back down, it stops. So I'm looking for where does it stop, because it goes up the hill, stops, and then comes back down the hill. So I'm going to plug these pieces into the equation VF equals VI plus AT. So final velocity is 0. Initial velocity is negative 10. Acceleration 4.9. And then time. So you do 10 divided by 4.9, so it's roughly 2. Oh, shoot. Sure, it's 2 seconds, but I'm looking for the displacement. So this was a really bad equation to use. Let's use a better one. VF squared equals VI squared plus 2AD. There we go. Final velocity 0. Initial velocity negative 10 squared plus 2 times 4.9D. And you solve that for the letter D. It's 100 divided by like 10, which is 10. Square root of 10 is like 3. So it's going to end up being somewhere around. No, it's 10.2. So doing all the math, 10.2 meters. That was a bad estimation there. 10.2. Question 3. What do we got? Same box, same incline. What is the minimum coefficient of static friction? What's the minimum coefficient of static friction? So again, still have gravity going straight down at 98. When I break that into the force perpendicular, 84.9 and 49. My normal force is 84.9. Now, getting rid of, it wants to know friction. What's the minimum force of coefficient that's going to do this? There's only one equation that involves the coefficient. It's the force of friction is the coefficient times the normal force. So I know that the force of friction, if you're going to stay still, the minimum it has to be is 49. That way, If it's being pulled down the hill at 49, friction is opposing you at 49. So those are fighting. So the minimum it can be is 49. This force of friction, 49. Normal force, 84.9. Coefficient. So 49 divided by 84.9 is like 0.4 something. 0.577. That's the minimum coefficient such that I don't slide. Next problem, it's initially at rest. Now they're giving you the static friction and the kinetic friction. So static friction, kinetic friction. We know, number one, I know that it's going to slide because in the last problem, the minimum that we figured out, this needs to be 0.577. This coefficient, if it's smaller than 0.577, you're totally going to slide. So I think I can do some little inferences here that if this coefficient, it's got to be that sticky. And this is definitely less, even both of them. So number one, I'm going to use static friction as my beginning because static friction keeps you still. And number one, I know that it's slipperier than this. So I can use that 0.3 as my first judgment. Number one, will it slide? And since this is slipperier than that 0.577, it's totally going to slide. Yes, it slides. Now I don't use this anymore. This is only there to ask me, does it slide? And the answer is yes, it slides. Now, once it's sliding, I use the kinetic friction, 0.2. So again, all my forces, my force of gravity, which is again 98, I broke it down into its perpendicular, which was 84.9, and then the parallel is 49. My normal force is 84.9. So gravity, I'm going to take it away. I'm going to be pulled down the hill at 49, and now I can find friction. Friction is slowing me down. The force of friction is going to equal the coefficient times the normal. The coefficient, I'm going to use 0.2. I don't use 0.3. I'm going to use 0.2 because we already know it's sliding. So once we know it's sliding, don't ever use that static coefficient of friction again. And the normal force is 84.9. So 0.2 times 84.9 is going to be like 16.98 or 17. I can just say significant figure-wise. So my force of friction, 17. Now, when I use my F equals ma, it's the net force. This force cancels off this force, and I'm going to say that down the hill is positive, so I have a positive 49, and friction is opposing me at 17. My mass is 10. And now I can find my acceleration. So 49 minus 17 is like 32. 32 divided by 10 is 3.2. There's my acceleration. The next problem, number 5. Says the incline has now been shoved and it's traveling up the incline at 10. So everything is the same. So I'm just adding on to this problem. It seems like there's a lot of work to set this up, but really everything is the same to begin with. So remember, gravity is still 98 because I still have that 10. This force perpendicular is 84.9. Parallel is 49. Normal force, 84.9. I can get rid of gravity. I've replaced it with these two forces. And friction, we just found from the last one, was 17. Weight. When we travel up the hill, let's give you some motion things. My velocity is up the hill. When you go up the hill, remember, friction is always opposing your motion. So here's where this gets a little funky. Friction is going to be opposing me. So now in this case, I've got gravity and friction are both opposing me. So when I go to do this F equals ma, the net force, and we'll say that positive is down the hill, I have two positive forces in this case. So it's going to be 49 plus 17 because I'm fighting gravity and I'm fighting friction since I shoved it up the hill. If I shoved it down the hill, friction would be going up the hill because it always opposes motion. So in this case, it's 49 plus 17 is my mass of 10 and my acceleration. So 49 plus 17 is 56. 56 divided by 10, so my acceleration is 5.6. So then, how far, okay, displacement equals question mark. Initial velocity is down the hill, so it's a positive number, 10. My acceleration is still, oh wait, we're shoving it up. Ooh, gotta be careful. Since I'm shoving it up the hill, it's a negative 10. I'm sure that you caught that right when I said it. The acceleration is down the hill at 5.6. Whew, this positive and negative stuff is really gonna get me. How far? Okay, I gotta have one more thing before it comes to rest. Okay, so my final velocity is 0. I'm going to plug it into the equation that doesn't have time. So that's VF squared equals VI squared plus 2AD. Final velocity, 0. Initial velocity, negative 10 squared plus 2 times my acceleration, 5.6 D. So 100 divided by 11.2. 8.93. That's how far she goes. The difference, friction is going down the hill only because I'm traveling up the hill. That's friction opposes motion, and since my motion is up the hill, that means friction is opposing that. So that's kind of a funky little question with that one right there. I think in this one, all right, and number 6, our final one. The box has been shoved, and they throw us a little bit of a curve because they make it more sticky. So we know that it's already moving, right? So static friction, don't have to worry about it because we are already in motion. It is moving. It's traveling down. So my velocity is this way. Is 10 meters per second. I'll declare this right up front that positive is down. Same idea. This is still 98. I still have the same angle, still the same mass. So all of these are going to be the same. So this is still 84. Shoot, I should do that green just so it matches all the rest of them. It really doesn't matter what color it is, but 84.9, and then this down the hill at 49. So when I get rid of gravity, this is pulling me down the hill at 49, and then my normal force is going to be 84.9. Since I'm traveling down the hill, that means friction is opposing me. So to find my force of friction, it's the coefficient times the normal force. So my coefficient of friction is 0.6 because it's moving, and the normal force is 84.9. So if you take 0.6 and you multiply by 84.9, you end up with 50.9. Now that's interesting. My force of friction is 50.9. Check it out. Friction is this big, and gravity is this big. Friction wins, which means this thing is slowing down. So this thing is accelerating in that direction. And I can figure out what that acceleration is from F equals ma. my two opposing forces. These are canceled. So I've got a positive 49 because it's down the hill. And I've got a negative 50.9 because it's up the hill, and my mass is still 10. I can figure out my acceleration. It's like point something, pretty small. That's negative 0.19 meters per second squared. And that's uphill. That's kind of important. It's accelerating up the hill. So now, when I go over here, my initial velocity is I'm shoving it down the hill, and that's a positive number, 10. My acceleration is up the hill, negative 0.19. How far? That's a displacement. Does it come to rest? So final velocity is 0. So VF squared equals VI squared plus 2AD. Final velocity, initial velocity, the acceleration, negative 0.19 times my displacement. So 100 divided by, you put it to the other side, so this all becomes positive in the end, 263. 263 meters. All right, kids, thanks for sticking with me. Hope that you kind of saw some common threads between all of these problems. It's nice that I use the same angle and the same mass so I could save myself a lot of sine and cosine work up the front. But good luck. Keep it in there.